Hi everyone, welcome to my channel, Tudorlini Test Prep. Today we'll be going over Ottocento number 20, Probability and Two-Way Tables. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so what is probability? Well, probability is simply a number between 0 and 1 inclusive that describes the likelihood a chance process would occur. So here are some examples of valid probabilities. 0 represents the probability that something will never happen, and 1 represents the probability that something is certain to happen. Here are some examples of invalid probabilities. Notice how anything that's negative or larger than 1 is going to be considered invalid. And most importantly, the probability we find that by doing the desired counts over the total counts, desired over total. So here's just a really brief example. It says, which of the following cannot be the probability of an event? Well, I'm just looking for numbers that aren't between 0 and 1. So 0, 0.94, and 1 are all acceptable. 1.8, however, is too large. So that cannot be the probability of an event, so that's the answer. Okay, here's a more abstract one from an old SAT. I'll try to include more of these on the worksheet so that you can practice. So it says each of the whole numbers 1 to 24 is written on a piece of paper. We're going to shuffle them in a hat. Okay, so why don't we just start by writing down all the numbers from 1 to 24. And we desire the probability to find out the probability that the number is a multiple of 5. So to figure out the multiples of 5 that are there, you can just skip a count. So 5, that's one of them. 10, that's another one. 5 times 3 is 15. That's another one. 5 times 4 is 20. And if there were 25, 30 on this list, we would keep going. But we see the list stops at 24, so we're going to stop there. So we highlighted 4 numbers, so that's 4 desired out of a total of 24. And that simplifies to, you could just do that on a calculator, 1/6. Okay, so once in a very blue moon, they've asked questions in the past about this thing called the law of averages. So if you ever take a statistics course, one of the first things they teach you is that the law of averages is false, right? So we're going to go over what it means in a minute, but this idea that past outcomes have some kind of effect on the probability of a future trial is just not true. That's why I put law of averages in red. It's a fallacy. So very classic example you guys have probably seen before is like a woman has 7 boys and she wants to have an 8th kid, but she feels she's due for a girl. She wants to have by the way, terrible reason to have a kid. Okay, don't don't go into it hoping that they turn out a certain way. You should just do it because you want to parent another child. Anyway, I digress. So she's not any more likely to have a girl after the 7 boys once it's in the past, right? It's still a 50-50 chance that she gets a male or female child. Similar idea with you guys see like free throw shooters who are like doing hot or like having a bad day, doing cold, right? Maybe like a hot free throw shooter, people will say, oh man, that person's on fire. They're going to score the next one. And that's not exactly a chance process. There's factors that go into that, but still kind of the idea is the same. Like the past outcomes don't really have much effect on the future trials. So there's a question here about an unfair coin, like a weighted coin, and it wants to know the probability of it landing heads up on the 15th toss given this situation. Notice this key word, the student tossed it into the air 14 times. That's past tense. So that means it already happened. So the probability of it being heads on the next toss is completely the coin doesn't have a memory. It's not going to remember all the results from before or anything. So all that's completely irrelevant. It's just a distractor, red herring. The probability of it being heads is 0.8. On any toss, on any new toss, the probability of it being heads will be 0.8. So the answer is C. Lots of people would maybe put D if they fell for, it's like a trap answer, if they fell for the law of averages. You might think, wait a minute, 0.8 times 15 is 12, and I got 11 heads, so I'm like, but that's thinking like the mother, right? I'm due for a 12th heads. That's not really how it works. The coin is not omnipotent, is not gonna remember that there were 11 coin flips. That's just how many you would expect to get if the entire situation were in the future, but remember the 14 flips already happened. And more about this in a second. The first answer choices, it would maybe be correct if the question said, what's the probability of being tails? Okay, so the complement rule. So we use complements a lot in real life, and we also use this word in math a lot. We use it in geometry to talk about angles that add up to 90 degrees. Well, it's also two events whose probabilities add up to 1. So the complement is 1 minus that probability. So to find the probability of something not happening, you do 1 minus the probability that it will happen. So let's use the one we did before as an example. So the probability, it's kind of silly to do for this one because we wouldn't say not heads, we would just say tails, but just humor me. We're going to do a harder one in a minute. So probability of heads is equal to 0.8. So to find the probability of not heads, we would do 1 minus the probability of heads, and we would get 1 minus 0.8, which is 0.2. Again, we would just say tails, but lots of scenarios, especially with multiple characteristics, aren't just binary. They're harder to track. So saying not is actually something they do in the SAT problems once in a blue moon. Okay, conditional probability. So for these kind of word problems, you can just think of it like percent. All we're going to do is multiply them together. I just put this on here. You don't have to know this. I just put this on here in case someone asked me about it. So to find the probability of A and B, one way to do that is to do the probability of A times the probability of B given that it already has the A characteristic. And then there's this longer equation for A, M, B, and C. The only reason I'm even mentioning this is because there's like one digital SAT question, which we're going to do a similar version of. That kind of expects you to know this. Again, it's more of a percents question, but you can think about it in terms of probability. And why don't we do that since we're learning about probability? Now, I'm not going to write this whole big thing out because I'm going to have a hard time fitting it on the slide. So just so you know, we're going to use the second equation, and I'm going to label them with these colors, yellow, green, and blue. Okay, so this question kind of combines both of the two ideas we just talked about. So take a second to read it, pause it if you have to. Okay, so first things first, again, let's just do it in terms of probabilities. You can keep it in percent, but let's just do it in terms of probability. So let's change all these to actual probability values, decimals, by dividing by 100. You just do that on a calculator. And this first one is the probability of it being red. And then the second part says, of those, okay, so it's saying, given that it's red, the probability that it's triangular. Oh, that's the second term in the formula, right? The probability that it's triangular given that it's red. And then the third thing is saying, of the red triangular item, so basically, what's the probability that it's plastic given that it is both red and triangular? So we're just going to put those into the right side of that second equation, multiply them all together. So the probability of red and triangular and plastic is equal to 0.48 times 0.26 times 0.54. You just put that on a calculator. We get 0.067392. But notice the question says not triangular red plastic item. So we need to find the complement of that. So we're going to do 1 minus that probability, as we talked about earlier. And we get a probability of 0.932608. The answer choices report these in terms of percent. So let's change it back to a percent. We'll multiply by 100. And we get 93.2608%. And if we look at the sides, that is the options, that is closest to answer choice D. Okay, so probability is almost always tested in the context of the SAT via what's called a two-way table. So a lot of stuff at the beginning is good to know, but it doesn't help too much. These are more common questions. And lots of people on the channel have been asking me about it, I think because they're probably still being asked, but there's not a lot of these in the Blue Book app. So lots of people, there's not a lot of videos online going over how to do them. So here we are. So this is a two-way table. It literally means you've got rows and columns. That's it. And they're broken up by some kind of characteristic. The entries in the middle have both of the characteristics. So green spheres would be 4. We got 4 of those that are both green and spherical. Anyway, so just a couple things I want you to notice while we're getting started. So notice how the rows, those guys have to add up to the total at the end. So 4 plus 9 is 13. The columns have to add up too. 9 plus 3 is 12, just for example. This black line here is just to help you guys with the introductory problem. This bold black line. The questions aren't actually going to look like that on the test, so don't get reliant on that. And these numbers here are like the actual entries, the body of the table. If you add all those up, 4 plus 9 plus 12 plus 3, you should get 28, which is the number in the bottom right. Now, a very common mistake is people, when they go to add up the totals, they do 13 plus 15 plus 16 plus 12. I don't know why, but to get that 28, you only need to add up one of those sets of totals. Otherwise, you're double counting. So 13 plus 15 is 28, and 16 plus 12 is 28. And this number at the bottom is super important. In statistics, we call that the sample size. That's like the number of total people in your study. Probably a better informal name would be like the grand total, big total. I sometimes call it the total. Just give it some kind of informal name so that you put some emphasis on it, because a lot of times that is going to be the denominator in your probability desired over total. A lot of times that 28 is going to be your, that number in the bottom right is going to be your denominator. Okay, so let's actually tackle some questions. So it says, if a shape is selected at random, okay, well, they're all shapes. That doesn't really narrow it down. What is the probability that it is a green sphere? Okay, so the green spheres, there are 4 of them, and they're all shapes. So there is a total of 28 shapes in the table, that number in the bottom right. So the probability is 4 over 28, which simplifies to 1/7. You can just do that on your calculator. No arithmetic required. Now, which would you put? Well, I always say simplify. However, sometimes in the multiple choice, they actually leave the answers unsimplified, I think, to kind of maybe make it easier for you guys to see where the answers come from. So if it's multiple choice, sometimes it's simplified, sometimes it's not. So maybe it would be 4/28. Just proceed with caution. But on student-produced response, you always want to simplify. So if the question doesn't have answer choices, simplify it. There's no reason not to. You just type it in your calculator. And if you don't own a calculator, type it into Desmos. There's no reason not to simplify. Okay, next one. If a shape is selected at random, okay, that doesn't really narrow it down. Once again, they're all shapes, so we're probably going to use that 28, that number in the bottom right. What is the probability that it is a purple sphere or a green cube? Now, we haven't talked about this yet. You see this word or. For our purposes, that generally means we're going to add the counts. So or means add for our purposes. So there are 12 purple spheres and 9 green cubes out of a total of 28 shapes. So we're going to do the probability is 12 plus 9 over 28, or 21 over 28, which reduces to 3/4. So this is the real meat and potatoes, okay? This is the thing probably the vast majority of people watching this maybe don't already understand. So I call these target groups. So a target group is just a subset of the data we're interested in. And when we see a problem like this, we need to only consider the values from within the target group. This will make sense when we do a problem. But for now, look at these keywords. So if blank is selected at random, the blank represents the target group. So that's some keywords selected at random. Notice we were kind of already using that one, right? I said if a shape is selected at random, it's just they were all shapes, so that didn't really narrow it down into a target group. It was still just all of them. But we're going to go into more specific target groups, which makes the problem a little harder. This keyword given, the words that come after that tell you the target group. So given that this person is blank, that's your target group. And sometimes you'll see this phrase as like a fraction or a proportion. What fraction of the blank? And that's your target group. So you see these keywords kind of tell you what to pick out as the target group. Now, the target group is very often a particular row in the table, a particular column in the table, or sometimes it's something more complicated and you have to think a little bit harder. We'll go over problems for all of these. Okay, so notice before, remember I said before, if a shape is selected at random, again, doesn't really mean anything, they're all shapes, right? But here, notice how it says if a cube is selected at random. So what we're going to do is we're going to put a big box on our scratch paper around all the cube values. So I'm going to do that on the screen. In this case, the cube column. And it says, what is the probability that it is purple? Okay, so we desire it to be purple. So just looking in that blue box, there are 3 purples out of a total of 12. So the probability is 3/12, which reduces to 1/4. So you see, oh wait, identifying the target group using the keywords and then putting a big box around it makes it way easier to see what to do. You don't have to memorize some kind of fancy equation or some kind of conditional probability formula. You literally just put a box around what you want to look at and then figure out the desired and figure out the total. That's it. All right, so this one's worded a little differently. This one says the keyword is given. So remember, what comes after given is our target group. So we want the purple shapes. So I'm going to put a big box around the purple row. And we desire to find the probability of a shape that is a sphere. So we're going to do, just in that blue box, there are 12 spheres out of a total of 15. So the probability is 12/15, which reduces to 4/5. And finally, we've got another set of keywords here. It says, what fraction of the spheres are green? So these keywords here, fraction of the, so the target group is the spheres. So we're going to put a box around the sphere column. And we want to know what fraction of those are green. If it were a percentage, we would just find the fraction, then multiply by 100. So for green, there are, just in that blue box, there are 4 green shapes out of a total of 16. So the probability is 4/16, which reduces to 1/4. Okay, so now we'll do some more complex target groups. I personally, so this really isn't a two-way table. This is really just one way. This is just like a column, right? However, this problem, first time I saw it, threw me through a loop, and I figured it was worth mentioning. Kind of gets you used to this idea of a more complicated target group. So this is actually a graph, and I updated this to be current, of presidents' ages when they were inaugurated for their first term. So it says, of those presidents who were at least 55 years old when they were first inaugurated, what fraction were at least 65 years old? Okay, so you see this keyword. The question's kind of phrased backwards, but the idea is still the same. This keyword, like of, which we were talking about before, the part after that kind of tells us the target group. So it's just grammar. The question's just kind of worded backwards, you know. So the target group is at least 55 years old. So let's put a big box around all the values that represent at least 55 years old. So I suppose that's those bottom 5 rows. Let's quickly calculate the total in that box since it's not displayed on the table. So total is equal to 12 plus 7 plus 3 plus 1 plus 1. And that should give us 24. And now we want to find the desired. It says at least 65 years old. So that is just the last 3 rows. So the 3, the 1, and the 1. So the desired counts add up to 3 plus 1 plus 1, which is 5. So the probability is desired over total, which is 5 over 24, and I don't think that simplifies. So very tricky. It's like, oh, wait, so it's not just a row or column that could be a target group. Maybe it could be part of a row or part of a column. Very, very tricky. Okay, here's one the SAT loves. They give you some very big two-way table, and they expect you to pick out a very wacky target group. So it says one of the voters will be selected at random. Okay, they're all voters. That doesn't really tell me anything. There's 190 total. What is the probability of selecting a voter from group B given that the voter is at least 28 years of age? Okay, so this keyword given tells us the target group, at least 28 years of age. Now, this is kind of hard to see, but you see at least 28 years of age. That's the 28 to 37 column, and it's also the 38 plus column. So I'm going to put a box around those 2 columns. And just to make it very clear that those numbers at the bottom aren't entries, I'm going to just, with my pencil, draw a little line just to kind of show that those are the totals. That it's kind of separate from the body of the blue box. Okay, and we desire to find the probability of people from group B. So there is 2 entries in group B in the blue box, the 22 and the 8. So to compute this probability, we're going to do 22 plus 8, which I guess is 30, over however many total are in the box. You can compute that however you want. 56 plus 62, the totals at the bottom, I think is the easiest way. You could also do 14 plus 18 plus 22 plus 8 plus 20 plus 36. That would work, but I think that would just take a little longer. I don't know. You should get the same thing. And why don't we use Desmos just to show that we don't need to do really any of the computation by hand. And we get a final answer of 15 over 59, and that would fit in the Blue Book app. Finally, we have this brand new type of problem, which I based this, it's heavily inspired off one in the Blue Book app, but I did change it, and I called this Make Your Own. So make your own table from words. So I think they're doing this a lot, maybe because of the nature of the computerized test. It's kind of a lot of work to expect people to like just copy the table. It kind of just wastes time. So they might as well just have you come up with it if you have to write it down anyway. I think that's probably the thought process, but what do I know? So we need to come up with the two-way table for this problem. And you see the two kind of sets of categories are apple, orange, and then healthy and unhealthy. Now let's read where it talks about the apple trees. So there are 7 rows of apple trees, and it says each row of apple trees has 12 trees that are healthy and 8 trees that are unhealthy. Okay, so the amount of apple healthy trees is 7 times 12 because there's 12 in each and 7 rows. So 7 times 12. And then the amount of unhealthy would be 7 rows times 8 in each row. So 7 times 8. And then we do the same thing for the orange. So 3 rows of orange trees. We've got 9 trees that are healthy, 4 that are unhealthy. So the orange healthy is 3 by 9. And the orange unhealthy is 3 by 4. Now we compute those using our calculator if you want. And then we compute the totals just by adding up. And now all of a sudden we have a beautiful two-way table, and we can, if you've been following along up to this point, we can hopefully much more easily answer this question. So let's go do that on the next slide. Okay, so it says, what is the probability of selecting an orange tree given that the tree is unhealthy? Okay, so this keyword given, that tells me the target group. So unhealthy trees, that's the target group. So I'm going to put a big box around the unhealthy column. And we want to track the chance of getting an orange tree. So the desired would be 12 over a total of 68 in that blue box, because there's 12 orange trees in the blue box, over 68 total, which gives us 12 over 68, which simplifies to 3/17. So you see, this really isn't that different from the last question, just the challenge is going to be reading it carefully and slowly and carefully coming up with the table using the paragraph. Okay, finally, guys, we're going to just talk very briefly about extrapolating the probability, the sample proportion to the population. This is more of a statistics thing. It might have made more sense in another video, but I think this fits really well here, talking about probability. So the expected value that you will see in the future, right? Not from the past. The expected you will see in the future, totally starting from the beginning, right? Is equal to the proportion times capital N, where proportion, PROP, is the sample proportion, or what we've been describing as the table probability, right? Pretty much the same thing. And then capital N represents the population size. So we're just going to basically take the fraction we found, multiply it by some really big number, and that'll tell us how many votes or donations or something we expect to get. All right, so okay, so it says the table shows the results of a poll given ahead of a competition. These two channels look familiar. I know one of them. I've never heard of this other one. And and they were asked which channel they prefer for SAT preparation. Let's first find the total by adding them up. They did tell us that there were 750 viewers, but we probably should just go over that. Just be like, wait, they didn't need to tell you. You could have just figured it out by adding them up. And then capital N, the population size, is the 4,000 people who are going to be voting in the competition in the future. And notice this really key word, expected to win. So that's why I wrote that on the previous slide. That kind of tells us to do this. This keyword expected tells us, okay, we're going to find some kind of proportion and extrapolate it to the population, multiply by the population. All right, so let's crunch the numbers. Let's look at the results here. So Sattel Tutoring, he had a proportion of 486 out of 750. And if you multiply that by 4,000 on your calculator, you should get 2,592 votes. And Tutor Laney, he had a proportion of 264 7/50ths, and if you multiply that by the population size of 4,000, he got 1,408 votes. Okay, well, I guess by a final answer of 1,184 votes, the Screen Actors Guild Award for Best SAT Creator goes to Sattel Tutoring. Yep. Okay, well, it's time for the final review. Don't forget to download that worksheet that's in the description. Try to do it yourself first. I don't know. And really just comment anything in the comment section. Let me know who you're going to vote for next year, I guess. Let's go to the whiteboard. Okay, question 1. So remember, probabilities have to be between 0 and 1 inclusive. So this one's between 0 and 1. This one's between 0 and 1. This one is 1, which is okay. It can be 0 or 1. 1 just means an event is certain to happen. So this one here, it is negative. It is smaller than 0. So that cannot represent the probability of an event. So the answer is A. Okay, question 2. So I first wrote down all the numbers from 7 to 28. And the question wants us to find what's the probability of getting a multiple of 13. So 13 is a multiple of 13. That's 13 times 1. 13 times 2 is 26. The next multiple of 13 is 39, but that's not in this chart. And don't forget this, guys. They tell you there's 22 total numbers. You don't need to figure that out. We might need that for the future ones, but so the probability is desired over total. So we circled two numbers. So that's 2 over a total of 22. And you can use a calculator or Desmos for this. That would reduce to 1/11th. And that is the answer. Okay, question 3. So we want to find all the positive integers that are less than or equal to 180. So think about it. If I asked you for all the positive integers less than or equal to 3, that would be 1, 2, and 3. So that's 3 total numbers. So in this case, it's 180 total numbers. So we know the total is going to be 180. And now it says we want them to be even and less than or equal to 40. So there are from 1 to 40, right? That's 40 numbers. So 40 inclusive. We're not less than or equal to, not between. So it's 40, but then about half of those are even. So really the desired is 20. So the probability should be desired over total. So 20 over 180. And if you put that in a calculator, that simplifies to 1/9. Okay, question 4. So question tells us there's 1,000 numbers. So our total is just 1,000. Nothing we got to do there. And they're 4-digit numbers. That just means they're integers. They're whole numbers. It says, what is the probability that the number is greater than 3499? So we want to find how many numbers. It's not including the 3499. It says greater than 3499. So we want to know how many numbers are from 3500 to 3999 inclusive. So a little trick you can do if you're not seeing it, maybe you just use your intuition, but you can take the difference and then add 1. So for example, if you wanted to find the numbers from 7 to 9, count on your fingers, 7, 8, 9. That's 3 numbers, right? But 9 minus 7 is 2. So 9 minus 7 is 2 plus 1 would give you 3. So you got to add that 1. So 3999 minus 3500 and then plus 1. So that should give you 499 plus 1, which is 500. So our desired is 500. So the probability is 500 over 1,000, which simplifies to 1/2. Okay, question 5. So this is one of the ones we talked about. Remember, past outcomes have no effect on future trials for a chance process. It says the student tossed this coin into the air. It landed. Notice all this past tense. All these things already happened. ED means it already happened. The probability that it will land head side up is the same as it always is at the beginning of the problem, which is 0.75. And the probability that it lands tail side down, it would be 0.25. So that would be the answer if it said that. The past outcomes have no effect on this. The coin does not have a memory. It doesn't make decisions. Just because you expected a certain number doesn't mean that's necessarily going to happen. Okay, question 6. This is an area probability problem. We didn't actually do this in the slides, but hopefully you'll find it's very similar. It's very intuitive. So the area of a rectangle is length times width. So the area of the entire figure is 8 inches by 4 inches. So the total area is equal to 8 times 4, which is 32 square inches. And then the area of the unshaded region, it says this guy is 2 inches by 3 inches. So area is length times width. 2 times 3 is 6. So this has an area of 6 square inches. And now to find the area of the shaded region, we're going to do the total encompassing area minus the unshaded. So 32 minus 6, and that gives me 26. So I'll use another color for this. So this area is, that shaded area all around the picture is 26. So now the question says, what is the probability that the point is within the shaded region? Okay, so we're going to do probability equals desired over total. So we desire it to be shaded. So that's 26 square inches over a total area of 32 square inches. And if we put that in a calculator, that simplifies to 13 over 16. And that is the answer. Okay, question 7. First things first, when we don't see total rows and columns, you should just do that at the beginning of the problem on your scratch paper. So I'm going to add a total row here. So I believe that's 26. 3 plus 11 is 14. And then I'm going to add a total column off to the side here. So 16 plus 3 is 19. 10 plus 11 is 21. And now I can either add up all the ones in the middle, or I can add up one set of the totals. I'm getting 40 as the grand total number of objects. Okay, now we're ready to answer the questions. So we see these keywords here. If a blank is selected at random, okay, so the target group is a yellow object. So we're going to put a big box around the yellow row. Let me get a really bright color so you guys can see. And we want the probability that it's a square. So we desire it to be a square. Just look inside that box. There are 3 squares out of a total of 19. So the probability for number 7 is 3 over 19. Okay, question 8. So this one says, if an object is selected at random. Well, they're all objects, so that doesn't really narrow it down. So I think I'm going to use the grand total for my total, which is 40. So let's circle that. You'll notice here it says they're all objects, distribution of objects. What is the probability that it is an orange square? Okay, so let's look for orange square. So orange square. Okay, so that is this 11, I believe. So the probability for this one will be 11 over 40. Okay, question 9. So it says if an object is selected at random, just like the last one, that's not really a target group. They're all objects. So we're going to use the grand total, 40, which is in the bottom right. So let's circle him. And then it says, what is the probability that it's either a yellow circle or an orange square? So we're going to find the counts of each of those and then add them to get the desired, just like we did in the slides. So let's see, yellow circle, that's 16. And then orange square, that is 11. Looks good. Okay, so we're going to do the probability equals desired over total. So I'm going to do 16 plus 11 over 40. And that is 27 over 40. Does not reduce, so that is the answer. Okay, question 10. So we have this keyword given that the object is a circle. Okay, so our target group is just the circles. So I'm going to look at the table and I'm going to put a big box around the circle column. So that is this one. And it says, what is the probability of selecting a yellow object? So we want to see just in that box, what's the probability of selecting yellow? Well, in that box, there's 16 yellow objects over 26 total objects. So we're going to do the probability is equal to 16 over 26. And let's see what that reduces to. That gives us 8 over 13. Okay, question 11. So this one says, what fraction of the, so that's some keywords telling us that the target group is going to come right after that. Tomato fields where herbicide was needed. Okay, so we're going to look at where herbicide was needed. Okay, so that is this column right here. And it says, had observable discoloration. So discoloration observed, that's 12 out of a total in that box of 32. So the probability is 12 over 32. Let's see what that reduces to. That is 3/8. Okay, question 12. So it says, given, so after that comes the target group, the tomato field did not have observable discoloration. Okay, so let's look up. Did not have observable discoloration. That is this row here. Okay, now let's look at what it's asking us to find. Where herbicide was not needed. Okay, so in that row, herbicide was not needed for 6 out of a total in that row of 26. So the probability is 6 over 26. And that reduces to 3 out of 13. Okay, question 13. So this one says, if a tomato field is selected at random, well, they're all tomato fields, so that doesn't really narrow it down. That just tells us we're going to use the grand total, that number in the bottom right. So let's circle that 56. We know we're going to need that. And then it says that herbicide was not needed and discoloration was observed. Okay, so herbicide was not needed and discoloration was observed. I think that's this one. So 18 tomato fields had that. So the probability is 18 out of 56. And that reduces to 9 over 28. Okay, question 14. If you don't know, the first guy, Red Hulk, is often president in the Marvel Universe, and the second guy, Lex Luthor, is sometimes president in the DC Universe. Anyway, so you add those two numbers up, or just read the question. They tell us there's a total of 800 voters. And then we're going to extrapolate this to the population because they told us it was selected at random. We can do that. We're going to do the proportion times capital N. The population size is 3975. So let's figure out how many votes each person we would expect to get. So for Thaddeus, we would get 544 over 800 times capital N, so 3975. And then let's see what that is. It's 2703 votes. And then for Lex Luthor, we would do 256, the proportion in the sample. In other words, the probability is a pretty similar idea. 256 over 800. And then we're going to do times 3975 again. And you should get 1272 votes. So Thaddeus will win by the difference, the positive difference of 2703 minus 1272. And that is 1,431 votes. Okay, question 15. We've got the same precedence table as in the video, but it's asking us a different question. So it says if a president is selected at random, but it says something specific, a target group, with first-time inauguration age 45 to 64 years. Okay, so I'm going to put a box around all the cells that represent 45 to 64. So 45 is here, 64 is here. So it's all of these rows. And the total will be all of those entries added up. So 7 plus 13 plus 12 plus 7. And that gives us a total of, let's see, 39. And we want to know what is the probability that the first time inauguration age was 50 to 54 years. Okay, so that's 13 people in that box. So the probability will be 13 over a total of 39. And that reduces to 1/3. Okay, question 16. It says, given, and then after that tells us the target group, the student attends a public school. So I'm going to put a big box around the public school row there. And then it says, what is the probability of selecting a student with age 4 to 8 years? Okay, so that is 68. That's that one. Out of a total of 194. So 68 over 194. Let's see what that reduces to. That reduces to 34 over 97. Okay, question 17. So once again, we see some keywords here. If a student selected at random, the part in between tells us the target group, who is at least 9 years of age. So that could mean they're either in this row or they're in this row, the 14 to 18. That's at least 9 years of age. That's bigger. So I'm going to put a box around both of these columns. And again, just to kind of remind you, those are the totals at the bottom, guys. It gets confusing when you have more than one row or column. Okay, we want the probability that the student attends a private school. Okay, so in this box, private school is the 16 and the 50. And then the total in that box is just these two numbers added up, the 110 and the 132. So the probability is 16 plus 50 over 110 plus 132. 16 plus 50 is 66. And then 110 plus 132 is 242. So 66 out of a 242 total. Let's see what that reduces to. That reduces to 3/11. Okay, question 18. So it says, given, what comes after that tells us the target group, the student does not attend a public school. So in other words, the student attends a private or charter school, the other options, right? So let's go and put boxes around that. So this is a little weird because the rows aren't next to each other, but you could still see this. So I'm going to circle the private row and then kind of concurrently circle the charter row. And again, you see it's just really important that we are kind of ignoring this public school row. We don't care about that. Told us not a public school. Okay, so the total is these two added up, 102 and 54. Let's see what it's asking. It says the probability of selecting a student age 9 to 13 years. Okay, so 9 to 13 years, that is this 16 and this 20. So 16 plus 20 over 102 plus 54, over a total of 102 plus 54. Okay, so let's write that down. Probability equals 16 plus 20 over 102 plus 54. So that's 36 over 156. Let's see what that reduces to. That is 3/13. Okay, question 19. So we've got a circle. It says 3 non-overlapping regions. I don't know, maybe that looks something like this. I didn't really do a good job drawing it to scale, but region 1, that's 3 pi. Region 2, that's 15 pi. And then region 3 is 24 pi. So first things first, we should probably find the total area of the figure. So the total area is all those added up. So 3 plus 15 plus 24, that's 42 pi. And then it says, what is the probability of selecting a point that does not lie in region 2? So in other words, it must in region 3. So that means it must lie in region 1 or region 2. So the probability is going to be region 1, region 2. So that's 3 pi plus 15 pi over the total area of 42 pi. And that is 18 pi over 42 pi. And hopefully you guys are seeing, oh, wait, the pi's just kind of go away. That's convenient. So it's 18 over 42, but I think that reduces. So let's see what that reduces to. 18 over 42 reduces to 3/7. Okay, question 20. So really important, guys. This says the ratio of CD to DE is 4:3. So normally when I do this, guys, I put like 4x and 3x. Okay. To indicate that it's a ratio. However, it doesn't really matter. We're going to find a probability and we're going to divide. So like the ratio is going to get simplified anyway. So it doesn't matter what x is. So I'm going to just make x 1. So I'm going to just pretend you would get the same answer regardless. Why don't we just pretend that instead of 4x and 3x, it's 4 and 3. Still give us the same answer for this problem at least. So the radius of the small one is 4. But then the radius of the big one, you see, is 7. 4 plus 3 is 7. So we're going to find the area of the total figure. So the area of the total area is, so the area of a circle is pi r squared. So pi 7 squared. So that's a total area of 49 pi. And then we're going to find the area of the unshaded region. So that's pi r squared, so pi 4 squared, which gives us 16 pi. And then the area of the shaded region is the encompassing area minus the unshaded. So let's see, 49 minus 16. That is, so I'll start putting some of this on the picture. So this is, this area is 16 pi. And then 49 pi minus 16 pi gives me 33 pi. So the shaded region is 33 pi. Question, of course, wants us to find the probability that the point selected is within the shaded region. So we're going to do probability equals desired of 33 pi over a total area in the figure of 49 pi. And you see, once again, the pi's will cancel. And 33 over 49 does not reduce. So the answer is 33 over 49. Okay, question 21. This is one of those ones where we have to make our own two-way table. So why don't we just do that before answering the next two questions? So it says we've got 8 rows of apple trees, and each row of apple trees has 7 trees that are healthy, 5 that are unhealthy. Okay, 8 times 7 is 56. And 8 times 5 unhealthy, is 40. So those go there. And now we're going to look at the orange trees. So 6 rows of orange trees. And each row of orange trees has 3 trees that are healthy, 9 that are unhealthy. Okay, so 6 times 3, that's 18. And 6 times 9 is 54. So that goes here. That's the orange unhealthy trees. Now I'm just going to use addition to find all the totals. I'll just do that off screen real quick. Okay, now we're ready to answer the question. So we see a keyword here, given, that tells us the target group. So the tree is an apple tree. So we're going to put a big box around the apple tree row. And we want to know, what is the probability of selecting a healthy tree? Okay, so that's 56 out of a total in that box of 96. So let's go down here. The probability is 56 over 96. That reduces to 7 over 12. Okay, question 22. So to find the expected amount of trees for each of these categories, we're going to do the sample proportion times capital N, the population size. So it doesn't have to be a voting question. You could extrapolate this to any context as long as it's selected at random, representative, anything like that. So we want unhealthy apple trees. So let's see, unhealthy / apple. And it's out of the total in the proportion. So I know I'm going to need this number in the bottom right, 168. So let's circle that. And then how about I'll do the first one in yellow. So unhealthy apple trees, that is here. So that's 40. So he's going to be proportion times N. So 40 over 168 times the population size, which is 2,520. So let's say 40 over 168 times 2,520. That's 600 trees of that type, 600 unhealthy apple trees. Now we're going to do the healthy orange trees. So let's do that. So healthy orange, that is, I'll do that in green. That's 18 there's 18 of those out of a total of 168 in the sample. So I'm going to do 18 over 168 times 2,520. And I am getting 270. So to find how many more, that's a keyword that tells us we're going to subtract them. So the positive difference is 600 minus 270, which gives us 330 more of that type of tree. Okay, everybody, thank you so much for watching until the very end of my video. I worked very hard on it, so I really do appreciate it. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Be sure to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying